there's a couple of classrooms I have to tend to, so I'm actually gonna start the stream and the recording now.
Okay, that's
Just
fine.
let you know you're live.
Okay.
Uh-oh.
Did Wayne just said somebody tweeted load live?
Yeah. He did it 2 days ago, though, so if you haven't seen a problem already, you probably
Oh,
have
okay,
one.
never mind.
I was telling him that I thought that came under the heading of good problems to have.
Yeah, yeah. No, it's just he just now pinged me with it. I'm like, oh, I'll be
Well,
busy.
Charlotte was doing her social media thing and came across it
Oh, okay.
because, you know, that's what Charlotte does.
Yeah.
You gotta get her a set of LII Musketeers or something.
Little antenna.
That's right, the little things on the spring.
Yeah.
The My Favorite Martian stuff.
Okay. Are you also gonna record me with Bob Glass?
There you go.
No,
You know, there's some for whom that is an inducement.
Not sure there's much point since it's being recorded anyway.
exactly.
Is it being, are they being live broadcast?
No, I think they skipped. Well, I don't know if they are or not. I thought they had
Pretty much.
not wanted to do that.
I have 4 drinks a year.
They started wanting to do it again.
Are we going? Where are we going?
We're all up to the top.
Okay.
It's a party. Have a seat. Well, here. I'll go this way. I don't know if I have ever recommended this to you or not, but get on. Available through a defined mechanism known as YouTube. Defined in 6 parts. Yes. Get it off the video.
I don't remember what you said about this investor. Coffee's good.
backstage at SFO during rehearsals for the rain.
That's cool. We should check it out.
No, you'll get a big charge out of it. Strongly recommended.
I made my slides look like the class cards. I even did my little bio slide, the way they do, with the photo on the left and the text on the right, except I added a few architects.
We're all very far from down.
You know the weird thing about the design of this
Gotta have a good arm.
is if you don't sit in the third row back, you actually have a worse view because
Yeah, because that's washed out. And that's,
Yeah, well,
because that's really why you can't see anything up there. So you have to sit back far enough to take these TVs. So I think that's why in every session I've been in this room, nobody sits in the first couple rows.
And you get a lot more contrast off the plasma screens and off of that projectors.
all right, well, it's 10 o'clock, so I guess we're going to get see.
10 o'clock, it's over.
So I guess we're going to get started.
you gotta click on Dan time.
Yeah. Everybody have their hot breakfast? Everybody's bright-tailed, bushy-eyed? My name is Daniel Nagy. I'm from the Legal Information Institute out of Cornell University. That slide's more for my benefit than yours because it's been quite a conference. And this morning we're going to talk about high-performance infrastructure and talk about a little bit about the back-end data as well. And we're not going to talk so much about hardware very much, but we're going to talk about instance optimization, server optimization, how we tune some of the back-end stuff that we're using for speed, and basically what the way this talk was incepted was black boxing what we did to fix what we had been doing for years after we moved to the cloud and kept building. So to give you some idea of the kind of data that I'm talking about, this is a shot of Google Analytics. Don't bother trying to read the slides, just look at the graphic. But we at the LII get about 2.5 million unique visitors a month. And this is just shot during about a 30-day period. Of those 2.5 million unique visitors look at roughly just over 9 million pages per 30-day period. The traffic is bursty. This metric was taken during exam time, so you would see our traffic increase during that. You'll also see it. We see it increase periodically over the course of the year. We'll see it increase again during things like when the Supremes hand down their final decisions before they recess. So it would be very likely significantly higher than that, like the end of June, when the Supremes finally let out. The kind of back-end data that we actually serve, we have several back-end data stores. We have about a 70 gig MySQL database, 70 gigs worth of data in the MySQL database. We have an Exist database, which has about 23 gig in XML documents. We have an Allegro graph that sits back there. It's a triple store database. It's got roughly 3.5 million triples. The Allegro graph is what faces more or less production for us right now. It's what people can actually touch from the outside. And then what we have working in the back that we're just developing on right now is Sesame with a backer of OWL-M. And that has roughly 25 million triples in it right now. And we moved from Allegro graph to Sesame OWL-M because we ran across an ontology that was going to cost us, that was going to incur about 125 million triples. And we ran into an issue with Allegro graph not being able to deal with that amount of data. The kind of data that we have in the background, on the back end, we have a whole bunch of government regulations. We maintain corpuses of US code, CFR, FedReg, that kind of stuff. We have the court decisions, which of course, as Thomas has said during this conference, was the LI's bread and butter initially, Supreme Court decisions. We don't do so much district stuff anymore, but we did. We have product data. That's the kind of stuff that's largely contained in the triple stores, agricultural and drug bank data. We have statutory data. And then we're starting to work on getting what we call associated government documents. And that is trying to figure out how to attach things like guidance documents to certain sections of the CFR. And the associated government documents will likely be, well, I don't know what they're actually going to be stored in, but it's going to comprise a relatively large chunk of data for us. And then the other kind of data that we have on our website is biographical data about our staff. This is Brian. He's one of the engineers that's been there the longest. He couldn't be here, but he'll be pleased that he's here. So I got into the LII about 1 million years ago. Sometimes it feels like it. And when I first got there, we had iron. We had a server room sitting on top of a 6th-floor tower at Cornell, which is great for cooling. That was sarcasm. Right? And we had hardware in various states of life cycles. And we had various kinds of hardware as well. I mean, I think we had a Spark station when we first got there that was actually serving Supreme Court data. But what we were doing at the time was we were serving pretty much flat HTML. So it's just the .html file largely served through Apache. And that's all we were doing. And it was good. I mean, that was the infrastructure that we needed at the time to serve what we had. And we had capacity there as well. I mean, we had machines that we could move around and do whatever. But following along with the model of Disney, we built, keep moving forward. So the LI kept moving forward. And boy, did we build. I mean, we just kept innovating and adding features and trying things, and we failed, and we tried something else. And so as we were doing this build-up, as we were starting to ramp up the site and make it more relevant to patrons, add features that people want to look at, we started creeping the seams a little bit. And on top of that, as I said before, we had hardware in various stages of life cycle. So we started having hardware failures. Now, at first, this wasn't a really big deal. At first, it was we could take this and just retask a machine or combine a machine because we had the extra capacity to do it. And it seemed to work at the time for us. I mean, we were scaling properly with the iron that we had in the room. And then we actually built out a little bit more the hardware infrastructure. We actually added a Linux virtual server cluster, so we could maintain because at the time that was when Slashdot was there and all that other stuff. So we would get the equivalent of Slashdot, so we had to have something to hold a load. So we actually had more capacity than we needed at the time. But we still began to have scaling problems because we started to do a little bit more stuff with the back-end data. So even with the LBS cluster, we were having scaling issues, and where response time was going down, we were having hardware failures. It was finding harder to put stuff, and it was also inhibiting the way that we would innovate because we would want to do something and not really have a place where we could safely land it. So this is about the time that everybody started to want to move to the cloud. And so Amazon popped up this cloud computing platform. And we looked at it and we said, okay, well, we'll give it a shot. And so we took the operation and started moving it gradually out to the cloud. And it allowed us to add features and allowed us to serve the patrons a little bit better. And at about the same time that we started moving the operation out to the cloud, we also started playing around with content management system. And in this case, it was Drupal. Now, we had been wanting to do this for years, and we finally got to where we had something we could put out there. And the first thing we put out there was something called Topics, which was like a legal dictionary, what is now WEX on our site. And we don't have the staff to move all of our collections over to CMS at the same time. So what we would do is we would move collection by collection. So what we had running out in the cloud was an Apache server, MySQL database, and then we would move collection by collection as we had the time to actually convert it to the CMS. So the first bit of overhead that we added to this were these long, drawn-out rewrites, mod rewrites, so that it wasn't really apparent to you whether you're looking at a piece of CMS content or you're looking at one of the old collections that were still flat HTML. And the mod rewrites were actually adding some overhead to the response time out of the systems that we had built. And we scaled. And boy, did we scale, and it got to be a little bit like a kid in his candy store. I mean, when you can just spin up an instance in a couple of minutes and get extra capacity to do whatever it is that you want to play with at the time, it's very tempting to do that. And we did that. I mean, if we wanted to add a wiki and we had no good place to put it, we would just spin up a wiki instance. If we wanted to do blogs and we had no place to put a blog, so we put it up there. If we had a developer that was working with a piece that needed some underpinning that we didn't have already, updated version of Ruby or an updated version of PHP, I would, instead of upgrading the stuff on the dev server, especially if he was doing something that they would classify as dangerous or that it might break some of the other code base, we would just build out another little playground for them to be in. And we all got messy. We weren't cleaning our room. So Keanu Reeves came and made us stop. But it wasn't really Keanu, it was Tom and Sarah that came and said, well, you know, for what we're doing, you know, maybe 30 servers, instances are a bit too much. So, so we started going through this process of kind of optimizing what we had and resharing what we had. So this was one of my favorite quotes from Terry Pratchett. So we had actually done something to ourselves by not optimizing, right? We had actually kind of set ourselves on fire. And so we would solve almost any, we had the hammer, and the hammer was that we could just add capacity to solve any problem we had. We weren't optimizing code. We weren't optimizing the machines themselves. We weren't optimizing the back end to work properly. And so as we're going through and doing this, we are actually, we're planting little landmines in our continuum. And we're getting around it by just simply adding capacity. If we see a machine breathing heavy, the assumption was, but since the code worked, well, the machine just wasn't big enough. The instance wasn't big enough. We just built a bigger instance. So we had built code queries and infrastructures that worked, but they didn't work optimally. So all we would do is every time something started breathing, every time something started smoking, we would just build more. And then the other thing that we started doing too is that because we would go through these really heavy development cycles, and because our release engineering left a little bit to be desired, we would leave tools laying around the shop floor. So when we would do something like move a collection from the flat HTML and we'd CMS it, that just kind of got left. The flat stuff would just get left. So we had all this, and the little tricks and stuff we used to serve that flat code got left too. And every once in a while something would find it. A crawler would find it, or like a .mil would find it, and it would just, since it wasn't doing what it was supposed to be doing because part of it had been taken away, you'd start seeing this really aberrant behavior. So we also had to start going and cleaning up the tools that we had left laying around our shop. So we started having performance issues. And that initially showed itself as long load times on the page, if you were looking at it, from the CMS side of things. And I think at this point I should describe that one of the things that we had added during all of this was we added the exist database. And what the exist database is, it's basically an XML document repository query. And at the LI we have kind of a unique back end because a lot of the data we get from the GPO, and it comes as XML. And pretty XML, but it comes as XML. So we validate it as best we can, we cram it into an exist database. And then what our Rockstar programmers were doing was they were writing modules to serve things like, and I use the CFR a lot because I can remember those letters. So what the CFR will do is if you query the CFR, the node exists but the data doesn't. What the module will do is it goes out, pulls the data out of the exist database, crams it into the MySQL database, and pulls it back out and completes the node in Drupal. So this is how you actually get data. That sounds really cool because it allows us to maintain both the document repository in a standard format the data wants to be in and a CMS. It adds an awful lot of time to the initial query for the CMS. So we would get around that by pre-instantiating the CMS, and we use Drupal's idea of lazy instantiation, which I guess if you're using it for what it's supposed to be used for is great. The way we use it, it's just a way of us getting content into the CMS. So what we would do is we would use a tool like curl we would use a tool like wget, and we would just walk our own tree, our own web tree, and cause the CMS to pre-instantiate. Now this drove up load across when we would do this, so we would do it at night. And we would do this so that the data was already in the CMS. Wouldn't have to go through and pull it out of Exist, which can be a little pokey. It's not really, Exist really isn't built for speed, and there's no way it really can be. So at that point in time, we were still getting really long, well, we weren't getting long page load times. We had moderated our page load time, but we were getting them high enough to where it was affecting, or we felt it was affecting our patrons looking at our stuff. And it was, the pages were taking a couple seconds to render, and it wasn't doing SEO any good either. So one of the things we did, this was an organizational decision we made at the time, was to add a static page cache. Now, I always think about the static page cache. When I was going back and I was thinking about doing this presentation, that was actually one of the crossroads. Because the static page cache we chose was one called Boost. Now, Boost doesn't really lend itself to a distributed environment, nor did the CMS version of CMS we were using at the time, which was Drupal 6, lend itself to being clusterized really easy. So by layering the Boost static page cache, which doesn't cluster well, or you can't fork it, and on top of Drupal, which you can't cluster well, we pretty much trapped ourselves in serving our data off of one instance, at least for the time being. Now, we could have tried something else at that point. The other way we could have gone on this fork in the road was using a static page cache like Varnish. But that required a core hack to Drupal. So did the ability to cluster that version of Drupal also required a core hack to Drupal. And we really, didn't necessarily have the staff time or the resources to devote to doing that. So we chose the path of least resistance, where we got the most bang for the buck and solved our problem the quickest, was by adding a static page cache. And then, and life was good. I mean, Boost is kind of dumb. It runs off of the way the static page cache works. It runs off of mod rewrites. And there's a back-end Drupal module. So if you touch something that doesn't have a page built, the module signals it to go build the page, put a file on the file system, and then the rewrites check to see if the file is there. If the file is there, it'll just serve the page, the static page. Our data is largely static. We know when it updates, so it's not like, I mean, it may change every day, but we know what has changed. So we don't. I mean, the cache will occasionally auto expire if it goes really long, but normally we will go in, and we have a mechanism whereby we will go in, expire the cache ourselves, or just delete the files that we know have to be rebuilt, and then either walk the tree again to pre-build them, or just let them build by themselves, depending how many you did. So, but it's not really that extensible. Boost isn't, but it seems to work for us. So, and that got us to where we felt that we were able to serve the data comfortably. With the static page cache, we were in a position, or at least we thought we were in a position now, where the page load times were relatively low. The server resources weren't breaking the bank. We were able to get decent CPU utilization. We were able to get decent memory utilization. So we moved on, and we started looking ahead and trying to figure out how we could get just tweak the systems a little more. And now we're starting to go back and try to figure out how can we optimize the actual infrastructure to get a little bit more speed. So I went through this thought exercise where we looked at Miasm versus NODB. Now I know that that's kind of technical. There's some of the engines that you can run within MySQL. So the stuff that we had ran off of Miasm. That was the way that MySQL came stock. The other one that we looked at was NODB, and the reason we looked at NODB was because the next upgrade cycle in Drupal, from Drupal 6 to Drupal 7, pretty much mandates NODB. So we were kind of paying it forward a little bit by looking at NODB. And then the other reason to use NODB, Miasm is actually faster if you're doing a lot more reads than you are writes. The minute you start adding writes into the equation, Miasm starts to breathe a little heavy, and that's because it does, Miasm does table level locking versus NODB's row level locking. And CMSs, by their nature, are kind of chatty. They're always talking to the backend database, even if it's the right user session data, even if it's just the right logs, even if you just do housekeeping. So you're always getting a bit more talk with your backend database, honestly, than I actually suspected we were. When you start looking at at the queries that are happening at the database. There's always some degree of writes going on. So we went through an exercise where we converted most of the relevant tables for our CMS to InnoDB. And once we did that and went back and ran some metrics on it, we got about a 15% speed increase. Now, let me just drop out for a second and say that 15% is kind of a magical number. When I worked at Emory, and I had a bunch of students that were working with me when I was working at Emory. And a lot of them went to go do other things, and one of them went to go design chips for Intel. And he came back for a visit, and we were chatting, and I was asking him what was in the bullpen over at Intel, and he said, well, nothing really, because they were having trouble with the chip architecture at the time, that they couldn't get it 15% faster than the chip before it. And I said, well, why is it relevant? I mean, it's just kind of a, he said, because the human sensorium, at least when it's detecting speed, really doesn't detect anything just by casual observation 15% faster. If it's under 15%, you don't notice that it's actually any faster. So the kind of metric for doing anything, I mean, is if you can get to 15% by doing one thing, there's a perceptible speed increase. And we had by converting from MiASM to InnoDB, at least on the CMS data, we just about hit that 50% mark for a speed increase. So it actually was worth it. I mean, it would have been worth doing anyway, because it's kind of a game of numbers. You're working up. But right out of the gate, we got something that was noticeably quicker just by converting it to InnoDB. And then the other thing we get, and this is not really speaking to performance, but we also got a little bit more fault tolerant. InnoDB is by its nature a little more fault tolerant. It does logging and journaling, which it'll read back in if you ever have a failure. So we kept building. We always move forward, so we kept building. And one of the things we started looking at, we already had US code out in the CMS. We had most of the other collections out in the CMS. We finally cleaned up our house. We were serving very little flat data anymore at this point. Except, of course, what we're actually really doing is we are serving flat data because we're serving out of the BoostCap. Right? So one of the big collections that came online, and this is a shameless plug, for our CFR. And it, when we put it on, now these numbers that you're seeing beneath us, again, they came from Google Analytics, again, over a 30-day period. This didn't happen overnight. So the LAI's Code of Federal Regulations, in the 30-day time period when I took this and took these metrics, in and of itself gets about 1.5 million page views per 30-day period. And the other thing that I found telling about it when I started thinking about the traffic was that 32% of the people that come to our site, however they come to the site, leave through the CFR. So that at some point they jump in and look at the CFR. So that roughly a third of our patrons, regardless of how they came in, whether it's through the front page or whether it's through the Supreme Court decision, whether it's through US code, they wind up leaving the site after they've looked at something in the CFR. Now, this was traffic we didn't have before. So over a period of a few months, we added 1.5 million page views per 30-day period to our infrastructure, to our site, and queries back to the data. And we started having performance issues. And now here's where, it was a tipping point. At some point, we hit our limit, and we started having quite long page load times. And one of the metrics we started using for this was not how long the page took to load, but it's time to first byte. So it's the time after you complete your TCP handshake to the time you get your first byte of actual content. In some cases, that was during modestly loaded times, that was taken 4 seconds. During high load times, just the time to the first byte, not the time to complete the page load, was taken, could take between 7 and 10 seconds. We were getting high CPU on the instances, not so much on the exist backend, which sits on a little separate instance all by itself. We were getting extreme load on the web server. We were getting modestly high load on the backend MySQL server, and we were getting memory exhaustion in almost both places. It occurred. It was definitely traffic driven. When the East Coast would come online, we would start reading a little heavy. When the West Coast woke up at around 1 or 2 p.m. East Coast time, we started dragging ass. It was worse if we changed anything on the site because the search engines woke up. So if we added or updated like Title 26 which is tax, or CFR 23, which is tax, or 21, which is food and drug, you would get these huge upticks in search engines, which was definitely driving traffic up, and you could see it causing pathology on the site. It was definitely traffic-driven problems, and we would go into this kind of death spiral where you get memory exhaustion, and that would cause more load time, that would cause more connections to backup. So as we started looking further, one of the things we noticed is we had fired up NetStat, which is a tool, command line tool we can use on Linux to look at what the network connections look like. And we were seeing lots of time waits and lots of time closes on both the MySQL instance, the backend database for the CMS, and for the actual app server for the Apache Drupal site. We were seeing modest load on the DB instance. We were seeing high load on the web instance, and we were seeing long query times on both Exist and MySQL. And now, to explain what the time loads and time waits are, that is something the time wait is when you have the thing that's pitching the data actually going, I'm sending you more, I'm sending you more. So hang on a second, I'm sending you more. So the catching thing on the server side will wait. So if Drupal is throwing packets at MySQL and it's saying, well, I got more coming. Hang on, I got more coming. It'll keep the socket open, and that's called the time wait. The time close is when the server doesn't know what happens. It thinks the connection has closed, but has yet to receive the final FIN packet saying close it. And we were seeing tons of time closed, and we were seeing tons of time waits. And what was happening is we were actually getting socket exhaustion. And I think my 8th grade science teacher said it was like being nibbled to death by shrews. You know, it was just death of 1,000 cuts. And we thought we had done something stupid. I mean, at this point in time, because it happened relatively quickly, we just hit a tipping point in the traffic. The pathology had always been there. But the extra load that we were getting from putting the CFR online was tripping the pathology. And we looked for one thing that we had done recently that was causing this. We were looking for one magic bullet that we could fix that would make it work for us. There was no such item. What happened was something we had not even realized we were doing. So what we did is pulled everybody off of what they were doing, and we did a code query and data review. So the first thing that happened was we went and we looked at the X queries, we looked at MySQL. So X queries would be like Wayne, who's not here. MySQL would have been one of the other developers. We compartmentalized kind of our skill sets. We looked at the PHP module code. Again, it would be like Wayne looking at that, Wayne and Sarah. We looked at the data modeling, so that was everybody sticking their head together going, did we get the architecture of the data wrong itself? Did we do it right? And then we looked at the actual web and DB server/instance optimization. So this is a slide. To take the next slide is kind of a bad slide. It's a technical. Don't bother trying to read it. So you can start pre-glazing your eyes now. And I put the slide up there not because I want you to read. I want to be trying to read that. It's actually just the visual of it. Those are both X queries, and they both supposedly do the same thing. Now, the X query is what we use when we query the backend Exist database to get the initial document out that we can then stick into the MySQL database. And I don't know who wrote, and it was probably Wayne that wrote both of them. I know Wayne wrote the bottom one. They both do the same thing. But if you look at it, the top one is far more complex, and the bottom one is far simpler. And the top one it actually even scrolled off the screen. The bottom one has like 38 lines. The top one had like 62 for an X query, and it was causing a lot of lag time, both on getting it out of the Exist database and parsing what we were getting back to stick into the MySQL database. So when Wayne started looking at this, and I like this quote from him, and I'm not supposed to read it, but I'll read it anyway. One thing special about X query is that the selection operates like a left join. More about that in a second. So actually, the more precise you are, the worse performance, which is counterintuitive. Left join in DBA speak means is a memory hub. It's DBA speak for slow, right? It's an unoptimized query. So if you look at what he's got next, right? There's two separate queries there, right? And with the EG. The first one, even though it is more specific, actually return far more data, right? They both return the data we want. The first one returns way more than we want, and the second one only returns what we want. So Wayne was trying to be really good. He was really trying to target his queries only at the data we wanted, only to discover that we were getting far more data than we wanted. And it was taking longer to run the query, and it was taking longer to parse the data that we got back. So once we figured that out, that the X queries were kind of counterintuitive, we cleaned them up. And so even when you think that you're doing the right thing, even when you think you've written good code, it's not a bad idea to go back and make sure you actually are holding what you think you're holding, and you haven't actually shot yourself in the foot. Because this is some place where we try to do our homework. We try to be good about it.
Did you just sort of break down the different components and do some timing to
Yeah.
narrow it? So that's
Yeah.
how you
Yeah,
sort of
there's-
focused in.
Yeah, Exist has a query sandbox, so you can run the queries and see how long they take to come back, and that's how they discovered that it was So, and then the other thing that, and I think Sarah figured this one out, the money shot with XSLT, was that we just simply added indexes to a lot of the fields. And after we added indexes to a lot of the fields, you know how I told you that 15% was good? This added a 2-fold speed increase over what the queries that had been running before. So simplifying the queries, which actually does a lot more stuff for you than just making it run faster, because it also makes it easier to read. So somebody who's not really good at reading X queries can now look at that X query and figure out what it is, instead of somebody who doesn't, somebody who's kind of sort of familiar, then takes a half an hour to decipher what you've done in your X query. We also went through and did some code optimization on PHP, on the module code, and then Brian also did and took out a lot of left joins in just the MySQL queries that we were running. So, can we take a breath yet? Well, we had solved a lot of problems, but we were still having, and the load times got better. We were no longer having 7 to 10 seconds for first byte. It had gone down, but we're still getting between 2 and 3 seconds to first byte of content. That's still really high. I mean, from looking at the way, and that's, again, just for first byte. If you got a really heavy page, it's going to take a long time to load. But we had identified some pathologies, right? The time weights were actually being closed. The time weights were actually, when I think back on it, those were the most telling. If we had gone down that path before, we would have been able to figure it out. Because what was happening was on the back end, we had set stuff really high to get the code to run in development. So in the PHP settings, you can set both memory utilization and the amount of time the script is allowed to run. Now, in order for the developers and the engineers to work on this stuff, we had gone through and set the time that a PHP script was allowed to run for 2 minutes, 120 seconds. We had set the memory usage to be really high because at first we don't know what we're doing, so we use a lot of these resources. And once that we had the code written, it was never went back and optimized to try and get those numbers down. And likewise on the database side, the MySQL side, we had set the packet size really high because we moved lots of data, and that actually is still really high. But we also set the connection time really high to allow that big data to be moved for the unoptimized query. So what was actually occurring, and now you also have to remember that Drupal also has its own internal timing to how long it will let things actually run. So we were getting this really nasty death spiral. So if we would get a PHP script that would run too long, like a piece of module code that would run too long, if it would run past the 120 second mark that we had the PHP script timeout set for, it would just die and not tell Drupal. And if that happens, then you get all these closed wait states on both your web server and your MySQL server. Those are chewing up sockets. Every wait state represents, albeit a tiny, but a chunk of resources that can't be reused until that wait state goes away, right? And it also is hogging up memory utilization. So, and if a lot of times what would happen there is that you would get the white screen of death in Drupal. Sometimes the page would not load all the way, sometimes it would not load at all. If the internal Drupal timer caught it at some point, it would clean it up and it would WSOD on us. So we knew we had some pathology going on. And we did actually clean that stuff up, so and then we would use memory, and we would use CPU on the database side, which were causing already slow queries to be even slower, causing more things to be wait stated as we were waiting for the data to come back, driving up the driving up the script response time on the website, which was causing failures. So we had fixed most of that stuff. So our backends look pretty good, right? The backend data looked pretty good. We had gotten it so that we could drag down the PHP memory utilization. We could drag down the MySQL socket weights. The other thing we had done, and I didn't mention this before, the Exist database is Java-based. It is very, 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 very sensitive to its heap space. And it's also not particularly chatty. And what will happen is if you run out of heap space for Exist, it'll just write corruption into your database and not tell you unless you can look at the consistency check reports from your backups. So we were actually had to tune MySQL a little bit too, not for speed but for stability, because we were starting to get failures in Exist. So we got all that stuff. We got the backend straightened out. We got Exist straightened out. We got MySQL straightened out. We got the module code straightened out. So why do we still suck? I mean, why are we still getting kicked in the crotch about every day around 2 p.m. Eastern Standard Time? Well, there's only one other thing, is that we started looking at the actual Apache and the actual CMS. We started now. We've tuned almost all of the stuff that the developers can tune. We've tuned all the stuff that the engineers can tune. Sarah's gone through. We've gone through his DBAs and looked at it. So we start tinkering with Apache. And granted, now this is a slide that I don't like doing stuff like this, but these are the relevant directives from our Apache conf log. And the ones that we looked at the most here were the server limit, max clients, and max requests per child. And there is actually, and I flip back and forth between these slides, and I apologize for giving people seizures. There's an actual formula for calculating the max clients. And this is where it starts to get into art more than science, because you're sitting there watching basically top or HTOP to figure out what the child size of your Apache processes are. Now, let me drop back and explain for people that don't understand. Apache is a web server, and it runs as a program, but it'll spawn other little Apaches that are the actual clients that do all the work for you. And those are called children. And those children, depending on how much work they do and depending on the data they serve, their segment size grows. In other words, their memory footprint grows. So you have to, and it's individual to what you're doing. If you're just serving up HTML, the segment size doesn't grow that quick. If you don't have sloppy code that memory leaks a lot, your segment size doesn't grow that quick. If you have anything else, you can get the child size growing quite large, which you'll get memory exhaustion, which you'll get CPU exhaustion, and a death spiral. So you basically go through, and for a period of whatever, in my case it took a couple of days, just watch the server to see what happens during different points of time of the day, so you can figure out what your max child process size is. Now, that's also malleable. So once you figure out what your max client should be, you go back and you set your max clients to where you think you should be. The other directive that's important is the max request per child, because as I said, what that means is how frequently the child process will be recycled. Now, there's two ways you can set it. You can set it for how many hits that serves, or how many connections it serves, or time. You can set it for timing. We figured out the best way to do it is to set it for the max amount for how many processes it serves. We knew after it served so many processes, the segment size grew to where it was going to cause, it was beginning to get past where I was comfortable having the memory be for an individual child process size. Now, that will slow down the server, having a large segment size for your child. The other thing that will slow down your server is recycling those child processes too frequently, because there's overhead involved in cycling those for Apache. So setting it just right again, it's more of art than the science. You kind of watch it, you tinker with it, you change something. If you have traffic at the time, you can watch your traffic. If not, you can artificially generate traffic. And then you have to actually hit the right stuff as well. You have to have a URL list that you're looking at, so you know when people are touching something in the CFR. Oh, the CFR is causing child process size to grow this much. And we actually got that right. At some point, after a couple days of tuning, we got the child process size done, and we got the max clients and max servers set properly. So now the server is actually cycling the child process size, the children properly. It's actually it's got the right amount of servers to serve the data, or at least we think it does. But we're still seeing an awful lot of not so much time closes now. Now we're still seeing a lot of time waits, and I'm seeing it all on Apache. Now what Apache will do is, unless it's really busy, it will never refuse your connection. It'll never refuse the patron's connection. It'll put that connection in a wait state and wait for a resource to free up, wait for a connection to free up that it can serve that patron with, that incoming connection with. So when I started looking at what was causing the time waits, I had this big backup of these time waits just on the network stack. So I stepped out of Apache real quick because I thought maybe I was having literally something that came unoptimized from the Amazon spin-up, right? Because there's actually server level, there's actually systems level stuff you can set. And one of the things that people are kind of loath to touch, and with good reason, is there's an actual TCP keep alive directive for the kernel. And you can set it it helps the back-end system clean up time waits, time closes. And people are kind of loath to mess with it because if you get it wrong, you can actually not ever be able to establish an SSH connection to your box. So you change it with caution, and you don't really change it drastically at first. You change it in little increments. It doesn't require a restart. It'll just pick it up, and you can set the interval kind of low so that the system itself can clean up the time wait sockets and therefore free up more sockets to serve Apache hits. And when I did that, and when I got it right, or what I thought was right, I dropped my time waits down by about a third, which was good. Now we're starting to make headway. Now we're starting to realize that that the only bottleneck that I have left are the time waits. But there's more, because we weren't done yet, because we still had a lot of time waits sitting. We still had a lot of people waiting and sitting. They would complete the TCP handshake, but they still were, the time to first byte was still really high. So there is also a keep alive directive within Apache. And that keep alive means that you take a certain number of those servers that you set up initially, a certain number of the child process, and you devote them to something called the keep alive connection, which is when a patron or an outside connection grabs it, it'll hold on to it persistently and wait for more data to come down the pipe. And will only release it when it doesn't see traffic on that connection for any amount of time. And in order to make everything work early on, I had the ratio of keep alive settings to the ratio of overall Apache spin-ups I had, children I had spun up, set too high. I had a lot more keep alives than I should have. And what it didn't occur to me that was going to happen was because, say, when Google comes in, when a crawler comes in and crawls your stuff, since it's crawling you at a much higher rate, it's going to grab, it's eventually going to alight on those keep alive connections and hold them. And it's not going to let them go. So we were saturating, we were giving really good response times to things like Google crawling, right? And you can throttle those guys. I mean, you can say, no, only hit me once every second or so. But there's the Guangming stuff, or whoever the hell they are in China, they'll just give you fits because they don't obey any freaking directive, and they'll just crawl you as fast as they can. If they get a hold of the keep alive connection, they hold it. So the very last thing that we did that actually solved the problem at the very end, when we're done with all the other tuning, is we set the keep alive connections to be something a little more fair. So out of 200 servers right now that Apache will spin up, I'm only devoting about 20 to keep alive connections. That's enough to keep the search engines happy. There is system overhead involved in building up and tearing down the TCP connections, but it was worth it to actually get normal humans to be able to use the site again. And that was the money shot. I mean, this is a tool that we're using to see, and this is actually the time to first byte, and the green bar at the very top there for the main website. You'll see when I took the shot, time to first byte was down to about half a second. So now we're finally able, we have optimized the system as much as we can. We've undone all the sins of our past. We've re-optimized, or finally optimized the code, the queries, the servers, the instances. and now we're getting times to first byte of under a second, and this is during load. This is East Coast, West Coast, both online. So we're getting close to the end. A couple of tools we used, I'm a toolbox guy, and I like having a nice complete toolkit. When we're going through all this and you're flailing around looking for ways to get metrics on what you're actually doing, Navicat is actually a client-based tool that you can attach to your MySQL server with. You can basically manage your MySQL server with it if you like. I'm a command line guy, but the thing I like about Navicat is it's got a server monitor where you can monitor your server in real time. So you can connect to it, you can actually see the queries run. Now the queries just flash up and leave, but if you look at it enough, and for somebody who has no life that does that, you can kind of tell when you've got something aberrant going on. So all of our databases were parted out by individual users. They all have their own user in the database. So if I know if I'm seeing one hit it frequently and stay, that there may be something pathological going on with that particular collection. Any page load timer plugin, view from 10,000 feet, any plugin for any browser will tell you how long an individual page takes to load. We use Nagios as a system monitor. It actually came with a whole bunch of plugins, especially for MySQL, that we weren't really using. And even if you only go through it and install those plugins, just so you understand a little bit better what they do, and therefore understand about what your MySQL server is doing, it's worth it, even if you don't care to monitor it. The trick with those guys is to set it right. Because if you set it so that it never bothers you and everything is always green, you'll never know when anything is wrong. And if you set it to squawk so frequently you start ignoring the squawks, it's not really beneficial. So getting those plugins tuned properly is important. There's an Exist Query Sandbox, so when they were going through and doing the X-Query optimization, you can take the query, paste it, run it, see how fast it takes. AB is the Apache benchmark. That just kind of sprays my website with stuff so I can generate traffic. There's probably better stuff out there, but that's the one I know how to use. And in a pinch, you always default to your training, and that's what I know how to use. That webpagetest.org, that was the previous slide. And it's great, it's a free service. I don't know what kind of data they're collecting, and to be honest with you, in the heat of battle, I didn't give a crap. I just cared about how fast the server is running. MySQL Bench, MySQL Top, two MySQL tools. One is a benchmark, and one is like a top for MySQL. And then two system tools I found during all this that I really like. They're command line tools, so you don't need a graphic interface to do it. They run cursive, so they actually look a little prettier, is HTOP and DStat. HTOP is like super top with a nice little graphic bar that'll tell you how fast everything's going. And DStat is nice. It'll give you a snapshot of all the system resources, including memory, network, I/O, but it doesn't tell you what processes are actually generating that load on the server. It's just a snapshot of the server at the time. So you need to hit it with something like Apache Benchmark or do whatever you're going to do, so you know what you're actually, you're generating a load and then watching what your server does. And then real quick here at the very end, it never ends for us. I had mentioned before that we were doing guidance docs, and I don't want to spend a lot of time on this. I was talking about it a little earlier. The guidance documents for us are coming, that each agency puts them out, can put them out in a different format. So just crawling them is a pain because like FDA's website is slow. In order to get it to work in the first place for us, we had to rip the entire FDA website and crawl it just to get the data out of it. And then because they come in so many different formats, they can come in PDF, TIFFs, JPEGs, whatever, we're having to go through a conversion so we can actually get the documents in a format that we can identify CFR sites in. It's really, that's a grind fest right now for us. So we're trying to optimize that right now. And I always find it patronizing to tell you what I told you, but in the end, we should never be allowed to play with computers ever again because we just over ourselves. But I guess the takeaway here is that we did ourselves a massive disservice by not going through and doing the optimization. By simply throwing resources at the problem because the cloud made it so easy to do so, we had actually shot ourselves in the foot. We planted landmines in our continuum of resources, and we planted landmines in our cycles, in our development cycles. That once we hit a certain traffic level, the pathology that we had built in, simply by not optimizing stuff, simply by even making it hard to read, came back and bit us in the butt. So that's all I have. I can take questions now, or we can just wander around the building. Nick?
Did you look into anything in optimizing the TCP between say your app server and the database server at all? Did you have to look into that, or
Like just tweaking the stack, or
Or making sure you
running internal.
sculpt which availability zones you run stuff in. Stuff like
We
that.
do. I mean, we run them all. We run them all in. Well, what's 2B to us is not 2B to you. We run them all in East 2B, and we use the internal network to talk. We don't. In Amazon, you have two interfaces on an Amazon instance. You have one that talks to the zone it's in, and then you have one that talks to the outside. And what Nick is, I think what Nick is referring to is that you can set the connection to look internally, so you're not actually routing the traffic outside the availability zone. It stays in the availability zone, which decreases latency time amazingly over the network. The only other thing we really did to optimize it, well, we did the two things. We changed the TCP timeout, and then the other thing that we did was we have to mess with the max packet allowed size. We don't really have a choice. We move a lot of data in and out of the MySQL database, and we were running up against the packet size. So whatever we do, we're moving such big chunks of data that we have to have that packet size set higher. So any further optimization, like trying to get the window right, or trying to get it to not fragment, is just because the packet size is so big, we're going to incur a lot of debt just for that. So.
Do you use a single MySQL server, or do you separate your reads from writes, or?
No, we use a single MySQL server, and I mean that's something else we have to look on the back end as well. We just haven't had. Again, this is an ongoing thing. This is not something that we stop. We're okay now. We're always going to be moving it.
I know the next hobby horse that Sarah wants to ride on it too is that we're running a static page cache, as Dan mentioned, and there's a possibility of serving that out of something like Nginx that's a lot lower overhead.
Right, or putting something varnish in front of it, so it doesn't even ever touch the server.
How, what size instance are you using for the database server?
It's an XL. It's an
And your app server, is that also Excel? Or?
Yes. And actually, for the amount of hits that thing serves, it doesn't really breathe that heavy for an XL. I mean, it's relatively well optimized. It's not particularly fault tolerant, just running on. What is?
I'm rather
Yeah, me
surprised.
too.
Yeah.
Yeah, I mean, I spread anywhere between 3 and 5 or 7. I mean, with the load balancer in front, I
Right.
mean, it really keeps an even keel on stuff. We don't, it takes the spikiness out, especially for stuff that's like reasonably predictable, like exam time. So, you know, the week before exams, when a week before the exam stuff starts, I just add a couple of nodes behind the load balancer that are just sitting there.
Yeah.
I fire them up, I update them, run rsync to make sure all the configs are up, add them to the load balancer, and then and it'll knock.
Yeah.
You know, it'll take the weight. You know, if we were running it, you know, at 30% CPU across the 3 nodes that were there, I throw 2 on it, it all drops to 10.
Yeah.
Everything's faster and accurate, and it graduates through the spikes.
What Stan is being too nice to say, I think, is that he's got at least one boss who is using him as a stick to beat programmers who refuse to optimize code.
But Dan could have done his own homework too. I mean, he doesn't have to wait to be told by the boss to make the programmer not do that.
Get those programmers to learn about VirtualBox.
Yeah, well, no, but you know, but really, I mean, this also came about because organizationally, one of the problems we had is we bought everybody MacBooks, right? So and our
Still
guys,
VirtualBox.
our guys can be very insular. So they'll take their little MacBook and drag it back to their little cave and bang away on they used to do this, they don't do this anymore, and bang away on their code. And then when it came to release it, you know, the release cycle, it took forever to get it off the damn Mac and onto the damn.
I shouldn't tell this story, but we actually did have a programmer at one point who looked at me with the usual, you know, well, it works on my laptop. So I said, well, then perhaps we should invite the internet over to your, install it in your laptop.
But the other reason we can't do we're not clusterized yet is because when we pick Boost as a static page cache, because the spin up time for a node at that point we have to rectify the static page cache before the node will actually be functional. And at that point in time, you're adding enough lag time to the node spin up that it's almost not worth spinning up the node to try and soak this traffic spike.
Well, that would be what you would use something like like varnish.
Right, exactly,
Exactly.
exactly.
The
But
other-
again.
the other thing, of
core-
course, you can do is if you're using EBS, which, you know, everyone should use EBS, for, you know, you can reduce your node launch time
Snapshotting.
by having a script snapshot your stuff
Yeah.
more frequently. Besides, more frequently you snapshot, the faster the snapshot takes. So if
Yeah.
you
No,
have a, if you have a,
Yeah, I learned that recently when I did a snapshot on a terabyte PBS thing. Well, what I had forgotten about was it hadn't been running that long.
How snappy was it?
It took 22 hours.
Yeah. Enough time to have a sandwich.
So in the meantime, I created another one and rsync the
Yeah.
stuff over, and
Yeah.
that was a lot faster. But that's
let's say after the end of that 22 hours.
Then it's now it's
if you-
fast, yeah.
If you take another one, you know, 10 minutes later, it takes 5 seconds. You know,
Yeah,
it's
It
great.
does, yeah.
So-
Right, it's, and
Got a point.
Yeah.
And I actually found a spot in the documentation where they tell you that after. I was like,
Yeah.
why don't they tell you that? And they, of course, they
Yeah, but you know, if you make one thing that we do on one of our environments where we have something where we have a lot of static files, and at first we tried, of course, to use NFS to share between them. And NFS on Amazon is not advisable if you ever want to try it. Just don't.
I use it a little.
Yeah, I do too. I use it for things that I have no choice not to. But for anything where you're wanting to serve static files, it's just slow
Yeah.
stuff.
Yeah, no,
So when we realized that just wasn't going to work, but we had a thing where we had terabytes of static files that we needed to serve, lots of PDFs and stuff like that, that we were constantly getting more of, but we wanted more on one app servers. I rigged a system where we are snapshotting. We're snapshotting every 10 minutes. And my script, of course, also goes and deletes old snapshots, because if we don't do
Right.
that, you'll really run out of, you'll really start running out of your snapshot bill. But, you know, I create a snapshot every 10 minutes, because then it takes only a few minutes to take the snapshot. And then I turn around and I've got an rsync system set where I rsync it every 10 minutes as well.
Yeah.
To any running servers. And then when I spin up a new server, I have the script look for the latest snapshot, boot with it, and then do an rsync.
Do an rsync,
So it only has to rsync from 10
Yeah.
minutes.
So, but I think our next cut at it is probably going to be, because we need to move to Drupal 7, and at that point, clustering becomes easier.
Right.
Varnish support is built into Drupal 7, so we'll probably just re-architect the whole thing.
The other thing you're going to want to look at is CloudFront, as long as.
Yeah, I know, yeah.
Because I've been playing with CloudFront for the front, for caching our WordPress stuff, and aside from some architectural issues buried deep inside of WordPress, anyway, it doesn't have anything to do with how CloudFront works, or even the current version of WordPress, because I've moved stuff from old to new. But it was working, it works really well, and it's not terribly expensive.
Yeah.
And it makes a lot, you know, a lot of sense when you've got a lot of static files which you need to serve quickly. And I think there's work being done in Drupal 7 to do that sort of stuff. The other thing I'm looking at with Drupal 7 is, as we move to Drupal 7, I'm taking a hard look at Nginx. I've actually got some stuff running, not on the Kali side, but using Nginx in Drupal 7, and it's a lot faster coming off the server.
Yeah.
Then you can really see the bottlenecks in PHP.
Yeah. Yeah.
And that then sets up a whole other. In a lot of ways, it's sort of like moving the little bubble around inside the.
Well, that's the trick, though. I mean, the trick is to get to optimal as quick as possible. And there's actually PHP optimizers you can run, you know, to look at how optimal your code is running. We're just not running code, so we're not sure what we're putting in.
Now, I had problems with CloudFront when I was trying to use it, because CloudFront makes their decisions on expiring items in CloudFront's cache.
Not anymore.
Well, yeah, I heard that you can change that now.
Yeah,
But the
yeah.
problem is they would keep like a certain number of items, and they even say still in the documentation, even if you tell me don't expire your cash, I'm still gonna do it anyway when I feel like I should. I'm paraphrasing, but that's what it says.
Yeah.
And so the problem that we were having is, we'd load up a page, and first page load would be really long because it would go grab everything and then load it. And then I would have somebody on the other side of the country load the page, and it would do exactly the same thing. And then the next day I would turn around and try to load my same page again. It would take really long that first time because it would have to do the double fetch, where I'm fetching from. I try to go to CloudFront. CloudFront tried to fetch from something, and CloudFront wasn't running in the same place that
Right.
my EC2 server was running.
Yeah.
So it was almost like, I would request from a local server, which would request from across the country, which would come back to the local server, which would then send it back to me.
Yeah.
And then just one day later, that file was gone.
Yeah.
Even though I told it to expire that file
Yeah.
in
Forever.
6 months.
Yeah, I think that the things that people are doing now with CloudFront they're tying into S3 more, so they've got more control over the cache and control over where the files are getting
But
stored.
S3 itself is a
and
little
spreading
pokey.
it around, huh?
S3 itself is a little pokey, though.
It can be pokey, yeah, but, and there are different ways, there are like 2 or 3 different ways to set up CloudFront now, some of which seem like serious black magic to me,
Yeah.
but,
I looked at it when
it's, you know,
we had to do some stuff for the African LI a little while ago, and because of the way that they're regionally distributed, I looked at CloudFront for some of their stuff. I didn't have that much time to actually hash it out for them, but so they didn't get it. It looks useful for stuff like that, too, especially in those countries where connectivity can be an issue, so you're trying to get as close to the point of service as you can.
Another thing I'm fascinated looking into for performance is, and I was talking to you about this last night, is Google's compute engine
Oh, yeah, you mentioned that.
is now publicly available.
Yeah.
Their pricing is pretty much the same as Amazon's, but you can boot a server of any server size in under 30 seconds.
Which really makes on-demand scaling.
Yes, it is damn fast, and the latency to it is.
We were talking about, they must have
really,
dedicated
really low.
circuits
I was
running
getting,
through
and
stuff.
it has regions too, and I was trying to I booted up a server in New York, a server in California, right? And then I tried to have them talk to them, ping each other, and I was getting 10 milliseconds ping times. Between the two.
Yeah, you can, that's gotta be private circuits, there's no way you can do that over.
I mean, that right there is a distinct improvement in the database backend.
Yeah.
I mean, no matter where this is cited.
I mean, shoot, I
what's
run
already-
2 things in 1B or 1C. I run 2 of them in the same building, and I'm getting 45 millisecond ping times.
Yeah,
between them.
exactly.
And they're in the same freaking
Yeah.
building.
What are you guys getting?
We get about, what are we getting, between our database and our website, we're getting roughly about 35. It's not horrible, but
I guess that's a payoff for Google owning all that fiber.
that's, yeah.
wow.
All right, I think we're out of time, so everybody should leave.
All right, it is that's done.
It shows that Google throws money behind something.
Until we actually put up a MySQL cluster, we're gonna have desk files.
Yeah, I warmed him up there. Oh,
Oh, yeah.
no.
Yeah, that'd be my.
The mic is on.
No,
And I
it's
think they
just
are
launched
streaming
live,
now.
so I don't know how long it'll
Yeah,
be.
nobody uses it.
Yeah, Amazon usually does that too. There was a point in time when I was getting, 2 little booths, so it was great. Now I'm getting, 30 minute booths, 1 hour booths.
That would work.
I figured I'm going to find a place where I can do it.
You have something to say.
Right, yeah.
Yeah.
What do I have?